they want us to use Hoffman coding to encode these symbols with these frequencies, and then they also want us to find the average number of bits required for this encoding. All right, so let's first go ahead and go through the process for Hoffman coding. So let's first go ahead and make our trees. So we would have A over here, and so this is just going to be 0.2. Here we'll have B, it'll be 0.1. C, we're going to have 0.15. D, 0.25. And then E, 0.30. Or we can just put 0.3. All right, so now remember the thing we want to do, and I'll move this up here just so it's kind of out of the way. The thing we want to do at this point is find our smallest two trees here and then combine them. So that looks like it's going to be 0.1 and 0.15. So let's go ahead and just move these off to the side for right now. So what we want to do is turn this into one tree. And so the idea, remember, is we want to put our more frequent letter to the left because that would be represented by a 0. And then we're going to put the less frequent to the right, which is going to be represented by a 1. So that means we want to put C to the left of B. Okay. So then we would combine these two into 1. So again, remember, left is 0, right is 1. And then we want to combine these probabilities here. And so that's going to be 0, or the frequency, so that's going to be 0.25. All right, so now what we can do is get rid of that and then scoot these letters up. All right. So now at this point, what we're going to do is place this tree back in line with the others. So we're going to have this. So we have 0.2, 0.25, 0.25, and 0.3. So we still want to look for the smallest two. But in this case, notice that we have 0.2, and then we have two 0.25s, which would be then the smallest. So at this point, it doesn't matter which one you choose. So let's just go ahead and choose this first one here. So we want to combine these two together. And we want to put the more frequent to the left. So that means we would actually want to move this over here to the left side. And then, so over here, this is going to be 0. Over here is going to be 1. So then we add those up. That gives us 0.45. So then let's erase these. And then we can scoot these up a little bit. Okay. Don't know where A went. All right. So we have that. And that's 1. Okay. And then 0. Now what we're going to do is again put this back in line with the other ones. And then we want to find, well, what is going to be the two smallest that we have here for frequencies? Well, we have 0.25 and 0.3. So that means we're going to combine those two over here on the right side. And then again, remember, we want the largest frequency to the left. So that means we want to move D over here. Let me make that look a little bit different from my A. So D. And then remember, that means to the left we have 0, to the right we have 1. And then we're going to add these together, and that's going to give us 0.55. All right, so let me get rid of these, get rid of that. And then we can go ahead and scoot these two letters up. E and D. Okay. Now we do our final comparison here with these two. So now we're going to compare the frequency of 0.45 and 0.55. Well, 0.55 is more frequent, so remember that means this is going to be moved to the left. And then we're going to combine these two trees like so. So then this would be 0, and then that would be 1. And then you would see that 0.55 and 0.45, add those up, and that would give us just 1. So I'll just put 1.00. All right, so actually, let me make this tree look a little bit nicer. So we go to the left, we go to the right, then we have 2 nodes here. We go to the left and right. So notice over here on the end, that should be E. Here we should have D. And then over on the right side, we'll need to go out a little bit further. So for 1, so if we go out to the right again, that's going to be A. Going to the left, so that's 0. And then we have 0 and 1, and then we have C and B. Okay. So let me just go ahead and erase this tree here. All right, so this is going to be one possible coding that we could use. So let's go ahead and write them out now. So E, so that's going to be 0, 0. For D, so that's going to be 0, 1. For A, this is going to be 1, 1. For C, so this is going to be 1, 0, 0. And then lastly, for B, this is going to be 1, 0, 1. All right, so this is the coding we get using this choice. But remember, we had 2 of them that had the same probability, and we just chose the more dense tree. So you will get a slightly different coding if you use the other one, but that really shouldn't matter all that much. Okay, but now let's go ahead and figure out what the average we would use to code for here. So first thing we need to do is figure out how many bits we're using for each of these, so we can put that here. So bits, well, E has 2, D has 2, A has 2, C has 3, and B has 3. And now we just put down our probabilities for these, and let me double check what A was really quick. So A was 0.2, so then we have our frequency here. So this is 0.2. D is 0.25. Oh, that was A, 0.2 here. This was E, not A. And then E is 0.3. C was 0.15. And then B was 0.1. All right, so now all we need to do is multiply all these and then add them all up. Oh, and by multiply, I mean, so we're going to multiply it like this going across. So we'd get 0.6, 0.5, 0.4, 0.45, and then 0.3. And then we're going to add all of these up. And if you add all those up, you should get 2.25. So this here is average bits we will need to use in order to code any word. And then this here will be our coding scheme.